All right, here is section 7.4, and our essential question is how can you solve a polynomial equation? So we've been dealing with them and we've been simplifying, and now we're going to be solving these polynomials. So our learning targets, our first one is to use the zero product property, which we'll see in just a second. Our second one will be factor polynomials using the GCF. Hopefully you've seen GCF before. It's the greatest common factor. We've done this a lot when we've been dealing with fractions back when we were in elementary school a lot. And then our third one is to use the zero product property to solve real life problems. So the first thing I really want to talk about is when we're dealing with these polynomials, we want them always to be in factored form. So we know it's in factored form when it's written as a product of factors. And remember that product means we're multiplying. So here's a polynomial that's given in standard form. So I've got my x squared plus 2x. So I want to factor that first. So I find anything that's common, and here's my factored form, my x times the quantity x plus 2. So same thing with this second example. Here's my standard form, right, as because my exponents are decreasing. When I'm solving, I want to look at things in factored form. So that's just a big key thing here. So now let's look at the zero product property. The zero product property means that if the product of two real numbers, so if I multiply two things together, if that product is 0, then at least one of the numbers is 0. So what I can do is if I have a and b, and those are my real numbers, and I'm multiplying them together to get 0, then I know that a equals 0 or b equals 0. So that's going to help us when we solve these polynomials. So here we're asked to solve each equation. So the first thing I want to make sure that I'm in factored form, which I am, and I want to set my equation, my factored form, equal to 0. So now that I've done that, I can set each piece of that factored form equal to 0. Because here is the first thing I'm multiplying, right? And here's the second thing I'm multiplying. So I'm multiplying 2x times x minus 4. So I set each of those pieces equal to 0, and then I solve them. So here I'm going to divide by 2, and I end up with x equals 0. And here to get my x by itself, I add 4 to both sides, so my x could equal 4. So my solutions to this polynomial would be x equals 0 and x equals 4. So now let's look at part B. First, I notice that I'm already in factored form because I'm multiplying things together, and they're set equal to 0. So all I do is I set each piece of the equation, each thing that I multiply, equal to 0. So I'm going to have x minus 3 equals 0 and x minus 9 equals 0. So now I'm just solving for my two x's. So first I add 3 to both sides. So I end up with x equals 3. And then I add 9 to both sides for the second part. So I end up with x equals 9. So my solutions, and I'm going to end up with multiple solutions to the second one, are x equals 3 and x equals 9. So oftentimes you will also see that these solutions are also called roots. They can also be called zeros, but in reality they are the solutions. So whenever you see any of these three words, roots, zeros, or solutions, this is what we're doing and this is what we're finding. You'll see where these words come into play a little bit more, but they all mean the same thing. So here's your first monitoring progress. Try these couple and see how you do. And so now we're going to look at a little bit more complicated. So I'm going to solve each equation. So solving, remember, means getting that variable by itself. So here I'm already in factored form. So I've got 2x plus 7 times 2x minus 7 equals 0. And I'm set equal to 0, so I can go ahead and solve them. So I take each piece that I have and set it equal to 0. So then I have my 2x minus 7 equals 0. So now I solve for my x, so I subtract 7. So 2x equals negative 7, and then I divide by my 2 on both sides, so I end up with x equals negative 7 over 2. So now to solve this second piece, I'm going to add my 7 to both sides. So 2x equals 7, and I divide by 2. So x equals a positive 7 over 2. You'll start to notice some patterns when we're dealing with these equations and solving, that when I see patterns from before, they do something funny to the solutions. You'll see that coming too. So now let's look at B. Right, so I say I have x minus 1 squared, which is the same thing as x minus 1 times x minus 1, and that's equal to 0 because I'm told that up in my equation, right? So I set each piece equal to 0 and solve. So I add 1 to both sides. So x equals 1. And again, I add 1 to both sides, so x equals 1. So you'll notice that these ended up with the same solution. So this is considered what we call a double root. So just know that these ended up the same way. So now let's look at part C, right? So I see I have 3 things that I'm multiplying by to get 0. This zero product property still works here. So I'm going to set the first thing equal to 0 and solve for x. So x equals -1. That's my first solution. So now I'm going to set the second thing that I have equal to 0. Add 3, so x equals 3. There's my second solution. So my first solution, my second solution, and I can go ahead and find my third solution. By adding 2 to both sides, I end up with x equals 2. So there's my 3 solutions, or my 3 roots for this given polynomial, right? And it doesn't matter how many different pieces we have, we just set each one of them equal to 0 and solve for each individual piece. So here are some more complicated ones that I want you to try out and see how you do, especially this number 6. Go ahead and try this one and see how you do. So now we are looking at our second learning target, was using the greatest common factor, right? Our GCF from before. So our GCF, or the greatest common factor, is the greatest thing that's common in all of my terms. So let's look at my terms. So I've got 4x to the 4th plus 24x to the 3rd. So this can also be written, right, as 4. Well, let's back up. This can be simplified even further than that. This first term can be written as 2 times 2 times x times x times x times x, right? This second term, well, I know that 24 can be broken down into 6 times 4, but these can be broken down into 2 times 2, and 6 can be broken down into 3 times 2. So I can have 3 times 2 times 2 times 2 times x times x times x is my second term, right? So now I'm trying to figure out the greatest common things between them. Well, here I see I have a 2, and I have a 2, but I have another 2, and I have another 2. So now I see I've got 3 x's over here, and I've got 3 x's over here. So I can pull all of those things out from my terms. So I ended up pulling out 2 times x times x times x. So then I'm left with whatever's left within this first term, which was an x plus 3 times 2, because these are both non-underlined, and that's all I'm left with in this second one. So now let's go ahead and rewrite this using our exponents and simplifying a little bit. So I know that 2 times 2 is 4. I have 3 x's, so that's x to the 3rd, and I was left with x plus 3 times 2 is 6. So I know that this is the factored form of this polynomial up here at the where we started. So the first thing I did was I found the greatest common factor, which is this 4x to the 3rd. That's my greatest common factor. But then I could write the entire polynomial in factored form, which is here. So now that I'm here, I could go ahead and use the zero product property to solve for that. So now here's another one to try factoring out. Don't lose track of this negative sign. This happens often, right? It can't go away, so make sure you account for that. So now here we're asked to solve these couple of equations. So let's look at A first. So I already see I have everything over to one side, so it's set equal to 0. But I don't have anything I'm multiplying, so I first have to go ahead and factor that. So I want to find all of the things that are common in both of my terms. So I've got 2x squared plus 8x equals 0. Well, I see that both of these numbers are divisible by 2, so I'll go ahead and pull that 2 out, and then I see that both of my terms have an x. So that tells me that I'm left with, in this first term, I'm left with an x, because I factored out the 2, and 2 divided by 2 is 1, so I don't have to show a 1 here. And x squared divided by x gives me 1x, plus 8 divided by 2 is 4, and x divided by x is 1, so I can leave it like that, equals 0. Well, now that I've factored this entire equation, now I can use my zero product property and solve. So I set it up 2x equals 0, and then x plus 4 equals 0. And then just solve for both of the pieces. So I divide by 2 and end up with x equals 0. I subtract 4, so x equals -4. So these are my 2 solutions for this equation, for this polynomial. So let's look at part B. So the first thing I see is I don't have everything on one side. I have a couple of different terms, right? And to use the zero product property, everything has to be on one side and equal to 0. So I'm going to go ahead and get everything over to one side, so I'll subtract 15n. So I end up with 6n squared minus 15n equals 0. Well, now that I'm set equal to 0, now I can go ahead and factor what I see. So I notice that both 6 and 15 are divisible by 3, and I also see that I have an n in both of my terms, so I can pull that out as well. So I know the 6 divided by 3 leaves me with 2, n squared divided by n leaves me with n, minus, right, here's like that example on that last page I just showed you, 15 divided by 3 is 5, and n divided by n is 1, so I leave that there. Well, so now that I'm here, again, I use my zero product property, so 3n equals 0, and 2n minus 5 equals 0. So I divide by 3, n equals 0, and first I add 5, so 2n equals 5, divide by 2, n equals 5 over 2. So again, here are my two solutions for this polynomial. Just remember the steps that we did. The first step we did was we have to get everything to one side. So if you're taking notes in your notebook, go ahead and say that. So say step 1, get everything to one side. So then you know when you're looking back what you did. And then step 2, right? This is where we did step 2. I factored things. So that's always going to be our step 1 and step 2. Get everything to one side, and then we're going to factor. And then step 3, we use the zero product property. And that tells me that I set each piece equal to 0 and I solve. So I would go ahead and make sure you have all of these steps down because we're going to continue to follow them. Get everything to one side, factor, and then use the zero product property. Okay, so here are some things where you can practice doing that. Make sure you follow those steps from that last slide. So now we're going to look at our real life example or our real world example. So you can model the arch of a fireplace using this equation, y equals negative 1/9 times the quantity x plus 18 times the quantity x minus 18, where x and y are measured in inches. The x-axis, right, going across, represents the floor. So I'm supposed to find the width of the arch at floor level. So I'm going to click because they talk about a couple of cool things here. So I'm going to use the x-coordinates of the points where the arch meets the floor, right, so I can see where they hit here. At these points, I know that y equals 0 because when I'm on the x-axis, my y is 0. I haven't moved up or down at all, so my y stays 0. So I substitute that 0 for y, and then I solve for my x. So I start off by writing my equation. The first thing I want to do is I want to get rid of this negative 1/9. So I'm going to go ahead and multiply each side by negative 9, right? Because I'm dividing by a negative 1/9, and that's the same thing as multiplying by the reciprocal. So now that I have two things with my variables that are multiplied together, I use my zero product property. So I've got my x plus 18 equals 0 or my x minus 18 equals 0. And then I solve for x on both of those. And I see that these are the x points, the x values where my graph or my fireplace crosses this. So I see that the width is the distance between them. So I can go ahead and find the distance, which is going to be 36 inches. Okay, so I used all of the tools that I had with my zero product property to get there. So now here's your last monitoring progress. Try this one and see how you do. It's very similar to that fireplace one. Make sure if you start this, draw a picture to get yourself started. That's where I always have to go first. So now let's look back at our learning targets. Our first one was to use the zero product property. And the zero product property, remember, just tells me that if I multiply two things together and they equal 0, then one or the other one has to be 0. Our second learning target was factoring polynomials using the greatest common factor. And that will continue to come into play, especially in the next several sections. Just finding anything that's common in all of the terms that I can factor out first. And then our third learning target was using the zero product property to solve real-life problems, which we did when we looked at the fireplace. So now it's time for you to go ahead and start working on the homework for section 7-4.